Good morning all. Myself Prachi Agarwal, Assistant Professor in Ajay Kumar Garg Engineering College. The topic for my lecture is Amplitude Shift Keying. This is basically from the subject Digital Communication, BEC 601. The content I will be covering is what is modulation, what is ASK, block diagram of modulator, demodulator, advantage, disadvantage of ASK and the waveforms of ASK. So digital modulation is basically the modulation technique. As we all know that modulation can be done in the two form, like we have two types of signal. We have basically analog signal and digital signal. So in digital modulation, we are using a digital signal as our message signal, and carrier signal is the same, the analog signal. So digital modulation is a requirement of our like communication. It will be helpful for in the case of multiplexing, when there are multi users are there, so we need multiplexing. So digital modulation help us there, and also it can be used for long distance communication, and digital modulation basically can be done using three techniques: ASK, FSK and PSK. Why only these techniques? Because we know that the basic signal, like any signal, basic can be represented like this. Right. So this is any basic signal which is represented as xt is equal to a cos omega ct plus phi. So what is this a? A is the amplitude. What is there in this signal is like a. This omega is what? Omega can be represented as 2 pi f, so it is basically the frequency, right? And this phi is basically the phase. So in any signal, it is basically comprised of amplitude, frequency and the phase. So that is why if we are modulating any signal, so we need to change these things like amplitude, frequency and the phase. So this is basic signal representation, and basic signal, like we all know that analog signal, simple analog signal can be represented like this. So that is why we only work for amplitude shift keying, frequency shift keying and phase shift keying. Shift keying, amplitude, frequency and phase, I think you got now, but shift keying means that the signal is digital. So we are working on a digital signal since it is a digital modulation technique. So we are working on digital signal, so that is why it is amplitude shift keying, frequency shift keying and phase shift keying. If your signal is analog, purely analog message signal, then it is amplitude modulation, frequency modulation and phase modulation. So that those topics you must have studied in your analog communication, your communication system in second year. So in this lecture, I am going to discuss about ASK. So ASK is one of the important technique, digital modulation techniques. So ASK means amplitude shift keying. So it is a digital modulation technique. It transmits the digital information by varying the amplitude of carrier signal. So we are varying the amplitude of carrier signal in ASK. In ASK, a high amplitude carrier signal is used to represent binary A, and a low amplitude of carrier signal is represented for binary 0. So we all know that digital signal is like this, 1 0 1 0, right? If we need to transmit this signal, so we need a carrier signal. Carrier signal is basically that signal which can help us for long distance communication. It takes our signal, from you can say the transmitter to the receiver. So in the modulator part, we need a message signal and the carrier signal. So in modulation techniques, what we are basically doing is we are changing the carrier signal according to our message signal. So carrier signal is your high frequency signal, and that is analog in form. So it is like this, a high frequency signal. So it basically changing with respect to your message signal. So message signal, as we all know, it is a digital signal, right? And one thing more, these modulation techniques are basically, it can be asked that what is like, is there any technique which convert digital signal to analog signal? Yes, although we have digital to analog converters, but these modulation techniques are also such techniques, or they are also known to be such techniques, because here we are using a digital signal, and after the modulation, this digital signal is converted into a analog signal. So, you can say that these digital modulation techniques can also basically converting our message signal to our digital signal to analog signal, right? So basically what is happening is it involves superimposition of carrier signal and a digital message signal, right? The carrier signal is often a high frequency sinusoidal wave. It is a high frequency signal. So that is the important thing. Frequency means the number of repetitions basically it is covering. So it is a high frequency signal which serves as a carrier for the digital information. So this acts as a carrier for digital information for transmitting our signal. The binary message signal consisting of ones and zeros is used to control the amplitude of carrier signal, right? So the resultant signal formed after the superposition of message and carrier is transmitted over a communication channel. So what is this communication channel? We all know that our communication system is comprised of our transmitter, right, and our receiver, and there is something in between the transmitter and the receiver. So that something is basically the channel, right? This something is basically the channel. So this carrier signal basically help us to take our signal from transmitter to receiver over this channel. So this is about simple description of ASK. Now let's see the waveform. So waveform of ASK is like this, as I told already. Suppose your data bit sequence is 1010101, right? So carrier signal is like this. You need to bifurcate all these bits like this. According, like for 1, I have taken this. For 0, then again we have repeated 2 1, then repeated 2 zeros 1 0 1. Clear? So this is our message signal. This is our carrier signal, and the last one is the modulated signal. Which modulated? Amplitude modulated signal, or you can say the ASK signal. Modulated signal, ASK. Since we are studying ASK technique, so it is the ASK modulated signal. So do not get confused. This is message signal, or we can say it can also be known as modulating ing. That means it is going to be modulate, right? Carrier signal we all know, a high frequency signal, and the modulated signal is that it actually got modulated. So this is modulated signal. So now see what is happening here is 101 110 101. This is our basic data stream. So this is carrier signal. Now in ASK what is happening is wherever you are having 1, wherever your data bit is having 1, so you are having some amplitude, okay, and wherever you are having 0 in your data, in your message, so there will be no amplitude, right? So wherever you are having 1, we have amplitude. This is for 1, and wherever we have 0, there is no amplitude. So this is the main thing which we need to learn. Like in ASK, only amplitude is changing. There is no change on any other aspect, like no change in frequency, no change in phase. Only your amplitude is changing from high to low, from high to low, and low here means 0, complete 0. We have taken that if in 0 is transmitted, so in that case your carrier modulated signal is completely 0, right? So this is digital bit sequence, second one is carrier, and the third one is the ASK modulated wave. I think these waveforms are clear to you, and these waveforms are very, very important. Yeah, if your waveforms are wrong, your complete question, complete description, complete answer will get wrong, right? So waveform should be clear to you. Now, what is this modulator? Modulator, since in a communication system, as I told, there is a transmitter, receiver, and in between them there is a channel. So in the transmitter part, we need a modulator, and similarly in the receiver part, we need a demodulator. So whatever modulator is doing, the replica of that modulator is done in the receiver in the demodulator, right? So modulator we are studying, that means we are studying basically the transmitter part. So in ASK modulation, a carrier wave, usually a sinusoidal wave, is modified in accordance with the message signal. So this thing you need to remember, that your carrier signal is changing, it is modifying according to the message signal, right? So we are not changing our message signal. Message can't be changed. Whatever message you have sent, you want to send through our transmitter to the receiver, the same should go na. So that is why we are only changing the carrier signal. Message will not get changed, only your carrier will get changed, right? So the amplitude of the carrier signal is changed between the predefined values 0 and 1 to represent binary data. The carrier wave is represented by continuous signal, right? The carrier's amplitude changes between two levels, particularly 0 and 1. We all know this. So when the input data is 0, the amplitude might be lower. But when the input data is 1, the amplitude could be higher. So when we have a data 0, so amplitude is 0, or you will get some small amplitude as well, like your signal is like this, right? This is your carrier signal, suppose. So your modulated signal should be like this. This is 0. Right, but they are also in 0, also you will get to see some amplitude. So that amplitude is very small in the size, like this. So you must have seen in your labs that you are getting some amplitude. So that also you can able to see. But in general, we consider that for the 0, there is no amplitude. The changes in amplitude affects the carrier signal in accordance with the digital signal. This modulation technique is simple but can be susceptible to noise and interference, which can affect the accuracy of the received data. Since we are working only on the amplitude, so this type of technique basically is susceptible to noise and interference due to this, because we are changing only the amplitude. We are not working on the frequency and the phase. So these two aspects are also very important, and more importantly is the phase. Phase is very important thing. So that is why that is a basically this is about modulator. Then demodulator. Demodulator is it involves the extracting of original data. So whatever you have sent is whatever you have sent is over the transmitter, so that should come out as a actual signal. So it basically helps for the extraction part of the message signal, and the process reverses the modulation applied to the carrier signal. So because of that, the process at the receiver part is totally opposite to that we have done in the modulator. So demodulator of ASK can be performed through various methods such as envelope detection, coherent detection. So we can use envelope detection, we can use coherent detection. Coherent detection is the technique which basically help us to take as a replica of your transmitted signal. It basically works on using the synchronous modulation techniques, like whatever you can say the phase you have taken at the transmitter part, modulator part, the same you are going to use at the receiver part. So that is coherent detection. And in the non-coherent detection, so the complete technique will get completely replaced. So this basically detection part can basically be done using envelope detection and the coherent detection. So this is the basic diagram of modulator and demodulator. So let me explain first modulator. So very basic diagram of a modulator is basically, come here. In the modulator, basic diagram of modulator is basically, this is a product modulator, this is our message signal, modulated signal, and suppose this is our carrier signal. right? So you will get a modulated signal. So here what is happening is we have a xt is our message signal. It is applied to ADC where it is converted into a digital signal, because we are not taking message as our digital signal here. So we need to convert it into a digital, because this is a digital modulation technique. So we need our message to be digital. So here in this diagram I am already taking a digital signal, but in this diagram if you are taking analog signal, so you need to convert into analog to digital. Then we have applied it to our modulator. So this is a product modulator which is basically taking this message signal as well as your carrier signal. So carrier signal is a high frequency signal. It is generated by oscillator, right? Then it is fed to a BPF. BPF is a band pass filter, and further it is basically going to a channel, and this part is the demodulator part. So again in the demodulator, since we are using a coherent detection here, so in the demodulator, this is a demodulator, so which is basically taking this modulated signal this is taking your modulating signal, right, plus your carrier signal, right? So modulated signal and carrier signal both are fed to a again the product demodulator, and then we have a LPF, low pass filter, because although your actual signal, your message signal is a low frequency signal, so we need a low pass filter for that. And then finally, since our message signal is in the form of a analog, so we need to convert digital into analog converter. Otherwise, if you are taking your digital signal only as the message signal, so you don't need to add this block, DAC block, right? So this is about modulator demodulator. And there is one thing more, the basic equation of your, it is cos 2 pi FCT, right? And this S1T is basically, this is your signal, modulated signal. ST is equal to under root 2 PS cos omega CT. This under root 2 PS is basically what? Amplitude. Amplitude can be, amplitude is basically what? Power is equal to amplitude square by 2. From that we will get, this is amplitude, and we know that power is equal to amplitude square by 2. So from here you will get A is equal to 2P under root, right? So this we have fed here, right? So this is under root 2 PS cos omega CT, and this modulated signal is again divided into two signals. Why? Because we are working on 1 and 0. So that is why S1T is basically what? Same, under root 2 PS cos 2 pi FCT, but your S2T is 0. So you just write, this is for binary 1 and this is for binary 0, right? So this is about modulator and demodulator. You can make a simple modulator, a product modulator, and you can show like this, and this is, then you have a demodulator part. The main thing you should remember is that we are using LPF in the demodulation section. Why? Because our message signal is a low frequency signal, so we need a low frequency, it should go out as a output. So we are taking LPF, and this is about modulator and demodulator. And the waveforms, again I have shown here the message signal, this is our carrier signal, and this is our modulated signal, ASK modulated signal. And further, if this is again fed to a demodulator, so we are feeding this signal to a demodulator, then same carrier frequency is applied to it, then we are having a LPF, it is passed to LPF, and further we will be getting our message signal, actual message signal as the output. So this is about modulator and demodulator. Now the advantages of ASK technique, it is one of the simplest modulation techniques which makes it easy to implement in both analog and digital systems. As we have seen, it is the very simplest technique. It is a cost-effective modulation technique. It is the simplest modulation technique. It is a cost-effective modulation technique. It is compatible with various transmission media such as radio waves, optical fibers, and wired communication system. We all know that communication can be done using these, various methods in the form of like channel. If we are communicating through if your communication is wireless, there is a transmitter and receiver, then it comes under the wireless communication, so it comes under the radio waves, right? If the communication is underwater, so underwater is basically where we are requiring optical fibers, so there the medium is optical fiber. So your transmission media, that means your channel is optical fiber. And if we are considering a wired communication system, so in the wired communication system also this technique is working very efficiently, right? So it is efficient in terms of bandwidth utilization, as it only requires two levels of amplitude, 0 and 1. Like there is no match in this because it works only on 0, 1. So for 1 there is amplitude, and for 0 it completely considered that there is no amplitude, no signal is there, right? These are about the disadvantages. So as I already told, it is susceptible to noise. It is more sensitive to noise and interference compared to FSK and PSK. Fluctuation in amplitude. Why? Because the fluctuation in amplitude caused by noise can lead to errors in data recovery at the receiver end. Since when 1 and 0 are coming, one by one, so there is a fluctuation in amplitude. When you are having a 1, you are having some amplitude, but when your 0 is transmitted, so there is no amplitude. Then 1, there is amplitude, 0, no amplitude. So that happens, regular basis after regular intervals. So in that case, it basically adds some noise. So that noise basically putting errors while getting the actual results in the form of data recovery, right? So bandwidth inefficiency, it can be less bandwidth efficient compared to other modulation techniques, because it requires more bandwidth, because it uses change in amplitude to encode data, right, which basically can limit the number of bits transmitted in a given bandwidth. So this is another disadvantage of it. Power inefficiency. So power transmitting signals at varying amplitude requires more power compared to constant amplitude transmission. Limited data rate. It is generally limited in terms of achievable data rates compared to PSK and FSK, because the limitation arises from the constant of how fast the amplitude can be changed without distortion, right? So these are the disadvantage, and the one more disadvantage is SNR, sensitivity. So it is dependent on SNR, signal to noise ratio. That means as the ratio between signal and noise decreases, the accuracy and reliability of the data transmission can be significantly affected. And the last is the lack of phase and frequency information. Since this is a ASK technique, so there is a lag in between in terms of phase and the frequency. So this is basically make more vulnerable to types of interference and distortions. So these are some disadvantages which are very important to write in your answer. So that is all about my lecture, and I think you understood ASK clearly. So thank you. Jai Hind.